Let's start getting to the real plot of the story, which is the relationships. We want to know how these data points work together, what interesting relationships are the plot of our story. When we look at two variables together, there's a number of combinations. We can look at two number variables, we can look at two non-number variables, or we can look at one of each, a non-number variable having a relationship with a number variable. Let's start with two number variables. And we're building a story about water and the equity of water, and we're interested in how many people have access to water. So we'll drag the percent sufficient to drink variable over to the rows, and we'll look at the averages so we make sure we're looking at what we want. And for this example, let's compare that to the GDP of a given country. So here we are looking at the GDP of a country that's been standardized in this data set compared to the proportion of people in that country with sufficient water to drink. And each one of these circles represents one country at one point in time. So right now we're looking at a relationship, but it's a little bit hard to quantify that relationship. So it might be helpful if we could look at some trends or some trend lines. And that's built in to Tableau. If you go up to the Analysis tab and Trend Lines and say Show the Trend Lines, immediately Tableau is now showing you a trend line, a relationship between GDP and the proportion of people in that country that have enough water to drink. And you can see from this line immediately that it's a pretty strong positive relationship, in that the higher the GDP is in a country, the more likely it is, the more people in that country that have access to drinkable water. Now, the line that Tableau shows you as default is a linear regression line. I'm not quite sure that a linear regression line is really the best suited for this data. So let's go back to the Analysis tab, down to Trend Lines, and say Edit the Trend Lines. So here we're going to see a number of different options. You can choose which model type between linear, logarithmic, exponential, and polynomial. And what these models are is essentially they each make different assumptions about the relationships that are within the data. There's extensive online documentation, but essentially, if there's not a statistician involved, stick at this point to linear or logarithmic. Linear means that there's going to be forced into a straight line, the trend line that you see, and logarithmic means that the line will be curved in a very specific way. You can see the change there, and a logarithmic line is actually probably more suited to our data, because if you look at this linear trend, it shows that as GDP increases, the proportion of the population that has water increases, and that increase will continue indefinitely, which is probably not the case. The logarithmic model here shows the same thing, that there's a definite rise in the percentage of the population that has water as the GDP rises, but that rise kind of tapers off and becomes pretty much of a steady rate as we get to the top end of the GDP, which is probably what happens in reality. So this is the model type in the trendline options. Your other options include putting other variables in as factors, which you might want to do for moderators and confounders. That's something we'll talk about later in another module. You can choose to allow a trend line for color. We'll keep that. That gives us more options later if we want to add other factors. Show the confidence bands. You can see that on, off, and then on. That shows the likely true value for this trend line. Force enters up to 0 is not something that you should do. And show recalculated line for highlighted variables is something you can do if you want to make an interactive viz for your own exploratory purposes. So this is great. What happens if we do allow a trend line for each color? If we add year, we can see, wow, the trends for each year are very similar, except for this one year, this kind of turquoise year, 2012. What is going on in 2012? you immediately will want to write that down in your notes. Something is going on in 2012. You have found a potential plot point from your story. You can't tell from this data alone what's going on in 2012. Let's drag gear over to the columns and separate it out so we can see more clearly the trend lines. And indeed, something is very strange in 2012. I wonder if this is a problem with the data, or did something really happen in the world that makes this trend change? So this is where you have to do some reporting on the ground to see if something happened in 2012 that would really make things different. And you also need to go back to your data and check if there's something that could have been different in the way that the data is collected. Are these differences statistically significant? To really truly understand that, you're going to need a statistician. But for the purposes of this course, we're doing exploratory data analysis. We'll again click on the trend line itself, and you can see that it gives you an R-squared value and a p-value. If we right-click again, we can describe the trend model. So this is allowing us to see much more in detail what's going on statistically in the models that we're building. And we're not going to go through all this. It's more information than you'll need to know for the scope of this course. And there's a fine line between knowing enough about statistics to mess things up and knowing enough about statistics to do it right. So if you really want to get into building statistical models, we'll offer a different course at another time on deeper statistical analysis. But this is more about statistical thinking. So at this point, you will want to look at the p-values here and see which terms in your models are statistically significant. So we're looking at the GDP and whether it's making a significant difference to your model. So is it making a significant impact on the percentage of people in your country that have enough water to drink? And this is broken out by years because our viz here is broken out by years. And so you can see in each of the years, 2006, the GDP is statistically significant. 2008 is statistically significant. 2010 is statistically significant. And how we tell if it's statistically significant is if the number is smaller than 0.05, then we're going to say, for the purposes of this course, that it is statistically significant. And what does that mean? For the purposes of this course, that means that it is possibly a real relationship, probably being caused by forces on the ground rather than just by chance in the data collection. We'll talk a little bit more about that in a subsequent model. And you can see here that this is the value for each of these terms. So in 2006, the log GDP has a value of 17.2 and a p-value that's definitely smaller than 0.05. And in 2012, you can see that the direction of the p-value, this is the only place where the GDP has a negative value, which is exactly what you're seeing here. This line is going in a different direction than all of these others, and that it does look like it is statistically significant. The overall model has a p-value that's smaller than 0.05, and the GDP has a model that's smaller than 0.05. This means that there are probably very good reasons to pursue the story of what was happening with water in 2012.